Hey, welcome to my talk. So, in today's talk, what I'm going to be talking about is something called keeping things modular with SPM or Swift Package Manager. So, before I jump into this talk, what I actually want to do is I actually want to talk a bit about myself for people who don't know who I am. So, a bit about me. So I actually started off with iOS development in 2016. So I used to work in a phone shop called O2, and I always used to just wonder like, how do people actually put apps on iPhones, which then led me down the road, and I got into iOS development. So I'm here now. Also, as well, another interesting fact about me as well is that I actually at my current company I'm a lead app developer. So I joined them when I was a junior, and I've worked my way up the ranks where I'm now the lead app developer on the team. Something else I like to do is I love anime. So if you're someone who likes anime, give me a shout and we can discuss, what shows are popping. And as you can see on the right hand side of the screen, I like to do some random things. So this is me actually competing in a chicken wing competition, a hot wing challenge, I should say. Just for the record, I did win it, but it was pretty difficult. But I like exploring new things and trying different things, food, traveling, whatever it is, just to keep things spontaneous. So away from the hot wings challenges, let's get back on topic. So in this tour, we're going to look at this app here. So this is the Rick and Morty app that I built. And as you can see, it features infinite scrolling. It's built using Swift UI with MVVM. Also as well, you can actually tap into characters and actually get information about that character. It's using async await with group tasks to basically perform multiple operations. We've also got a contactor screen within our settings screen, which has some very, simple validation using regular expressions, and you can submit the form. But if it actually submits the form, it doesn't actually do anything. It's just simulating a call to some kind of service. So you can see here I'm typing, and then I'm going to hit submit, and you can tell it gives me a message to say, hey, I'll submit, and it takes me back to the settings screen. So if you're actually interested in using this API, I've left a QR code on the screen here and a link to this service. But as you can see, it's a small app, but there's actually quite a few features with things that are actually going on. So when you actually look at our app here, you'll see here that these are actually the features that I've organized in a monolithic approach within the project that our app uses. So you can see how we have the character detail, we have the validator, contactors form, settings, episode, characters, modifiers, networking, model. And we've got a few dependencies as well that we rely on from Apple's Swift packages as well. So there's a few features here, and when you work in a team or if you're working on your own, a lot of applications tend to grow as you add new features, improvement, bug fixes, and whatnot. So although this looks small now, this could actually quite grow if you was to add new features to the application. So as you're adding more features to an app, what are some of the problems that you're actually faced with? Well, the problem is if I was inviting someone to work on this app with me, I can't actually work in isolation. So I don't know if you've dealt with this before, but I have plenty of times, to the point where I had an Xcode conflict when I was on holiday, and because I was the only one who knew how to solve it, I had to resolve it. But Xcode project conflicts can be quite nasty to deal with, so you can't really work in isolation without really conflicting in terms of adding new files and folders, which is something that you want to avoid because you just want to work on your task and crack on with it. Also, as well, as the application grows, so do the number of source files in your Xcode project. So what does this mean? Well, it also means that your actual build times will increase as well because you have more source files. So if I was to add a small feature to the application, I actually need to build everything all over again just to run and test that one specific part. That's if Xcode is smart enough to cache the build for me already. And finally, as well, if someone new joins a team, or if I stop working on this for a short amount of time and then come back to it, we've all been there again, we forget. So sometimes, and I could be bad for this, you forget to write documentation. How can we actually document our features so it's clear and you know the purpose of certain functions and why we've done certain things as well? Well, we can actually solve these problems by using something called modularization. So what is modularization? Well, it's a design pattern that was created to effectively do what the name says, work with small modules. So it promotes the idea of you working with small features and then building on top of features, almost like a bits of Lego. Also as well, each module has its own individual purpose. So let's say, for example, you're working on an app where a user are able to log in and register. The login will be its own module and the register will be its own module because that's the purpose of those features. On top of this, we're actually only meant to make our modules small. And the reason for this is because each feature should only have a small, amount of code in it because, each feature is purely isolated. So you should only ever include what a module needs. And you can actually define and make it clear in terms of how your modules work and interact with each other by using something called dependency graphs. So a dependency graph is a graph that shows the relationship between two modules in terms of if they depend on each other or what modules the application needs in general. So this is something that you would normally do in software design before you actually even write any of the code. It's kind of like writing a blueprint for how you think your app, the piece of software you're writing is going to work and interact with different parts. So, how does this solve our issue? Well, the first thing it does is it allows us to isolate our features. So, because we've now isolated our features into individual modules, I can't step on your toes and you can't step on my toes because I'm working on my module and you're working on your module. So, we can't really interfere with each other. Also, as well, we can also get a clearer view as well. So when we're working within our teams, we can actually plan out and make sure that our modules make sense. So for example, let's say if you had a register feature and a login feature again, you wouldn't really want the register code to be in your login module because registration should be handled by registration. Or if you had forgot password, you wouldn't want your forgot password feature to be in your login or register. So you kind of want to move that out into its own forgot password module. So by defining these dependency graphs and planning our modules, we can actually identify areas where code should sit. We're also able to integrate the new doc.c that Apple has introduced to Swift packages. So by using doc.c, we can actually write clearer and better documentation and also describe the purpose and function of objects within our apps. So using doc.c is way better than just writing a bunch of comments because you get a nice documentation similar to what Apple provides with their documentation as well. And you would also get quicker compilation times. So with the technique that we're going to talk about in a second, with this technique, what it will allow us to do is it will actually allow us to only build our individual modules in isolation. So because we're only building our modules in isolation and we're not packaging everything else, this will actually allow us to build our applications much quicker because we're only building that individual feature and not all the source files that the app includes. So when we actually want to do this, we actually need to paint a clearer picture. And the first thing we need to do when we're actually discussing our modules, looking back at our example before with our Rick and Morty example, we need to actually define some foundation modules. Now, a foundation module is something that the application needs or is the base layers in terms of the code that it needs to sit on top of to perform some actions. So the first one we'll go look at is models. So what are models? So the models would be the response that we get back from any API calls. So any of our codable objects will go inside of our models and it would actually live there. Another foundation module that we need is our networking. So we need to make requests to some kind of service, right? So our networking module would allow us to do so and would actually write a reusable and generic class that allows us to easily just basically use generics to pop in some kind of codable and it will literally decode it for us as long as we give it a valid resource. Also as well, we need a mapper. So the mapper is so we can actually convert our response to our DTO. If you don't know what DTO is, this stands for domain transfer object. And our domain transfer object is basically a model that we use for our UI. So we only give our UI what it needs. So there's some properties in our response from our API that we don't actually need our UI to include. And that's why we use a mapper to convert it and only give it what it needs. And then finally, we're also going to have helpers. So helpers could be anything from extensions, it could be anything that you just quickly use and reuse within your application to basically help speed up tasks. Now in our case, our helpers are going to be modifiers that we use in Swift UI, because we're going to be using a Swift UI application for it. And don't worry, in this talk, I'm not going to be debating about whether you should use Swift UI or UIKit. So the next thing that we need to focus on as well is our feature modules. So a feature module is anything that sits on top of a foundation module. So some of our feature modules within the application, our Rick and Morty one that we need is our settings. So we had our settings screen, so we're going to need that. Also as well, we're going to need a characters, because our characters needs to call some kind of API, map the response from a mapper, and we're also going to need to perform, build some other components that you want to display on the screen. Also as well, we're going to need a regex validator. So remember, our form had a regular expression validator. And finally, we've got our form. So our form is so we can make submissions. Now, you may be wondering, why is regex validator not a foundation? Well, the reason why I don't consider it a foundation and a more of a feature is because it's very possible that you may actually want to use just regular expressions to do some validations on its own as a standalone feature in an app. So that's why I've decided to name it as a feature and not a foundation module. So how does this look when you actually put it all together? So this is an example of a dependency graph, and as you can see on the right hand side we have our form, which also has an arrow to our regular expression validator. And what this arrow basically means is that our form depends on our regular expression validator. So what this means is that we can actually use some of the functions and some of the properties that we expose within our regex validator within our form module. So these two modules have a relationship with one another. So just so I can show you this on a bigger scale, when we actually translate all our foundation modules and all of our feature modules, this is what it looks like. Now, this might be a bit overwhelming at first to look at, but it's actually not that crazy. On the bottom, you can see that we have a box with all of our foundation modules. So we have our helper, models, and mappers. And at the top of this, you can actually see there's another box with all our feature modules. And all each colored arrow does is basically tell you which module depends on which one. So as you can see here, you can see with our characters module, this one actually depends on the most. So it actually depends on our helpers, it also depends on our mappers, and it also depends on our networking module as well. So that's three dependencies that our character module has in order for it to perform the actions and operations that it needs. And each one of these modules serves a purpose. So the helpers is so we can perform, some quick wins with our Swift UI extensions. Our mapper is so we can actually map the response that we get back from the service to our DTO. And then finally, our networking is so we can actually perform that response in the first place. But now that we've painted the picture for our modules and how they're going to look within our application, how can we actually translate this into our app? It's all good and well having a graph, but how do we actually use it? Well, we can actually use this using Swift Package Manager. Now, in this talk, I'm not going to go into too much detail about what Swift Package Manager is and how to use it and whatnot. I'm going under the assumption that you know what it is and you've worked with it before. But if you haven't, there's actually, loads of resources online that will, show you how to use Swift SPM. So with SPM, the reason why I'm using this as opposed to something like CocoaPods or Cartage is because this is a built-in dependency manager, meaning that we don't need to rely on any other kind of third-party services in order for us to build a dependency graph. It's all handled for us via Apple and built into Xcode, so it makes sense to just use this straight out of the box. So how can we convert this using Swift Package Manager? Well, the first thing we need to do is we actually need to build our package. So what I've got here is I've got a video that I'm going to talk through. So in this video, what we're going to do first is we're going to create a new folder called Rick and Morty API. And this is where all of our feature modules and foundation modules are going to live within, as you can see here. And then after we create that folder, we're going to CD into that folder. If you don't know what CD means, we're just going to go into the folder via the terminal. Then the next thing we're going to do is run this command Swift package init. And what this command does is it basically creates a Swift package within that folder, as you can see in the terminal. Now, if we want to open up our Swift package, we can do so by writing the following command, open package.swift, and that will open up our package for us within Xcode. And we can actually edit this and do what we need to do. But what we want to do is we actually want to edit both our package and our main app at the same time. So what I'm going to do is I'm actually going to cd into the root of the project and actually open up the Xcode file using this command. So now I've got my base talk project open. I need to actually add my Rick and Morty API into my app, and it's very easy to do. All I need to do is just drag the folder into my Xcode project, and Xcode is smart enough to pick up that this is a Swift package. Pretty straightforward. So now that we've got our package within our Xcode project, we're actually able now to basically build our features. So what we're going to do now is we're going to start to build each individual feature. So how do we define dependencies within a Swift package? Well, what we're going to do is rather than having each feature as its own standalone Swift package, we're actually going to define each feature within our main API and then define them as individual libraries. So the reason why I'm doing this is because it allows us, like I said before at the start, to basically build our features in isolation. So because they're individual libraries, it actually allows me to build these targets with only the source files within that folder. So as you can see here in the example, we've actually got a folder, and we're going to now rename our base folder that we had in our monolithic approach. And now we're going to create a new folder called helpers, and within helpers we're going to define a library in our products, and then within our targets we're going to say that this library that we've defined is going to be our target helpers. So now if we actually compare the two, the before and after, if you look on the before side, we've got our base folder with our modifiers, and on our right hand side we now have our folder called helpers, which matches the name that we gave it in the library. And within our helpers folders we've got our modifiers. So one thing to note is that when you're doing this approach, you need to make sure that the folder name that you create within your Swift package matches the name that you create in your folder directory, as you can see here where it says helpers and then helpers. So after we've done this, what we're then going to do is we're going to discuss why libraries are not multiple packages in a bit more detail. So the reason why I decided to use libraries and not multiple packages is because for me, it's easier to maintain. What do I mean by this? Well, think about it. We had close to 7 different folders that we're going to need. I personally don't want to maintain 7 different package.swift files. For me, it'll just be a lot easier for me to manage it all in one file. Also as well, these features are not something that I'm actually going to be sharing via, something like GitHub or Bitbucket or whatever it is you're using. They're going to be stuff that's local to this project. So for me, it doesn't make sense to host it. It makes sense to have it locally within the project and build it where it is. Also as well, Xcode is smart. So because in our package.swift file, if we actually define our dependencies within each library, when we actually package up our files or when we want to build our app, Xcode is smart enough to basically realize that I need this, run anything in parallel that it needs to do and cache it and then build your application. It helps us build our applications a lot quicker. So let's look at this now. So what we have here is we actually have our Swift packages actually mimicking and matching our folder structure. So you can see here within our Swift package, I've defined all the products and libraries that this package has. So all the features and foundation modules that it's got to have. And then if I scroll down, you'll see that one of the dependencies I have is Swift algorithms. And then within our targets, we've actually defined the libraries and the dependencies between each one. So if you actually want to define a link between 2 libraries, all you need to do in the dependencies is just define the name of that library. Pretty simple. And like I said before, Xcode is smart enough to basically pick out the dependencies that it needs and then build it and package it up and do what it needs to do. And you can see here in my example, I actually have a dependency on characters with Swift algorithms. It's very easy to define this using the product, defining the name, and also the package name as well. So it's pretty straightforward. So we have a problem. Well, what is this problem? So, because we've moved all these files into new places and whatnot, our main app is basically like, bro, where is everyone? So, what we need to do now is we actually need to fix all the issues that we've got when we're actually building our application. So, in this case, when I built the project, there was 44 errors because I moved things around. So, we need to fix this. So, the most common problem you're going to get is this one. So, when I'm actually using my API response model from the networking feature, or from the networking module I defined, my characters module is complaining, saying that API response doesn't exist before. Like, where is it? I can't find it. So what do we need to do? Well, it's a very simple fix. All we need to do is just mark that as public. And now that we've made it public, we're actually able to expose this object from outside of our module. And then finally, what we need to do is actually import our models module within our character module, because remember, they had a dependency within each other. And because we've now done this, it's now exposed. So we also have another problem within our app. And the other problem is within my settings screen, remember I had a contact form. Now, before in my previous app version where everything was just monolithic, it'd be able to find that you because it's within the folder directory. But now that we separated out our contactors form into its own module and settings into its own module, they have no awareness of each other. So how do we resolve this? Well, again, it's quite simple. All we need to do is just create a link between our contactors module and our settings module. That's it. So what we're going to do is within our Swift package, we're now going to define that form is now a dependency within settings. So now you can actually access any of the form objects that we expose within settings. And then all we need to do is to simply import form into our settings view. And then now we have access to our contact form view because we've made this public as well behind the scenes. So you can use this and it's aware of it in code. So when we actually look at this in our updated dependency graph, you'll notice that between settings and form, there's now a link between the two because there's now a dependency between the two modules. So how do we actually link all this together? Well, you can see here that within our main application, we've actually now got an error. So you can see that our base talk project has gotten a lot smaller because we've now moved out all our features into our Rick and Morty API feature. And now it's complaining that it can't find characters view and settings view, which does make sense. How do we resolve this? Well, it's pretty simple. All we need to do is just literally link our characters and our settings feature within our main app, and that's it. So let's see how we can do this now. So what we're going to do is we're going to go into our project and we're going to select the characters and the settings feature. So we need to select these two features and add them to our Xcode project. Okay, cool. Now, when we go back into our base talk project app, we just need to import our characters and our settings modules, and that's it. So remember, because we made our character and settings modules, characters view and settings views public, we're able to actually access this from outside. So now when we run this, you can now see that we've got the characters and we've also got all the features. You can click into a character and everything is working like it was working before. And you can see there that the build time for it was actually quite quick. And just to note, this is not an M1 Mac, yeah. This is just a straight up 2019 MacBook Pro. So this is not like a super rapid machine either that I'm using. So a few things to note before we wrap up is take a step back. So when you're actually planning your modules and working with your modules, you want to take a step back and look at the app that you're working on and think to yourself, should I move this into its own module? Should I create a link between the two modules? Or do I need to completely rethink about how I built this application because this really doesn't make sense in terms of how things are linking up? Also as well, you want to remember that Swift packages are actually fine. I know I use libraries for this, but if you're someone who wants to use Swift packages for this because you need to host them somewhere else or share them with someone else, or if you just want to just use Swift packages in general, there's nothing wrong with you doing that. The reason why I just chose to do this is because I don't need to host these features anywhere, and it's just something that's local to the application. Also, avoid dependency cycles. So if you're not too sure what dependency cycle is, it's basically when one dependency depends on another dependency, and then it just literally just goes around in a circle. So if you ever have a situation where A depends on B and B also depends on A, so you get a dependency cycle, you might want to rethink about your code, because you don't really want to have two modules depending on each other. It's kind of not right. So that's everything from me today in this talk. So if you enjoyed this talk, and I appreciate your time for watching it, I actually do run a YouTube channel where I teach, everything iOS, from UI kit, Swift UI, continuous deployment. I give career advice, everything that you need on my YouTube channel. So if you want to check that out, subscribe to it. I've got a QR code here, and I've also got a link as well. And also, if you want to follow me on Twitter, I've left the, my symbol here, and also the link as well. That's everything from me. I enjoyed this talk. Thank you, iOS Conf SG, for having me. I'll see you all in a bit. Deuces.